Well, again, one more aspect of inverses, operations on functions, is determining whether two functions are in inverse. And we already did this problem right here, and we already determined that the inverse of this one is this one, but there's actually a proof in order to do it. And basically, if you take the composition of functions, which was on an earlier lesson, and the composition of f of g of x is x, and g of f of x is x, then they are inverses. Basically what that means is if you take the composition of this, and it's equal to x, and then this of this, and it's equal to x, there you go. So we're going to go ahead and do that really quickly. We're going to take f of g of x, and we're going to take g of f of x. So here we go. We're going to do our g of x, which is 2x minus 6. We're going to take f of that. So that means for every x value that I see, I'm going to put in, instead of an x, I'm going to put in 2x minus 6. So here we go. That's 2x minus 6 plus 6 over 2. That comes out to 2x minus 6 plus 6. That's 2x over 2 equals x. Story checks out on this side, but you got to do it on the other side too to make sure. So my f of x is x plus 6 over 2. So for every x I see, I better put it into here. So I've got 2 times x plus 6 over 2 minus 6. That's the same thing as 2 over 1. 2's cancel. I'm left with x plus 6 minus 6. It's equal to x. So that's another way to prove if something's an inverse. Like I said, when you use logarithmic functions and square root functions with a restricted domain, mind you, mean inverse functions, that also means that the parabola itself, x squared, has to be a restricted domain as well. But that theory will come a little bit later. Okay. With that said, I hope that's helpful. Have a good day for now.